Hello, in this video we are going to learn how to draw the Lewis and VSEPR diagrams by determining the electron groups, the shape, labeling the angles, and discussing the repulsion between electron groups and how that affects the shape and angles of your molecule. So let's get started. So we're going to be working with bromine trifluoride, and the first thing we're going to want to do is determine the number of valence electrons or electron pairs. So let's go ahead and do that. We know that bromine has 7 valence electrons and fluorine has 7 as well, but it has 3 fluorine, so we're going to multiply that by 7, and we should get 28 valence electrons or 14 electron pairs. So now we're going to first draw the Lewis dot structure for bromine trifluoride. So we're going to start off with bromine as your central atom and 3 fluorines attached to it. We know that bromine trifluoride has 28 valence electrons and 24 of them are going to be occupied by the fluorine atoms. So let's go ahead and draw that in. After drawing these valence electrons, we still need 4 more. And these 4 electrons are going to be 2 lone pairs attached to this bromine atom. And now we're going to draw the VSEPR diagram, which gives you a 3D dimensional shape, which is what we want to see here. So we're going to draw this in pink. We have the bromine atom in the center, followed by the 2 lone pair electrons. And in this case, these 2 lone pair electrons are going to affect the shape and angles as well of this molecule, where these electrons want to be as far away as possible from each other, causing a bent shape here with the fluorines. And therefore the angle would be more than 180 degrees versus here that it looks linear. And therefore the angles between these fluorine atoms are going to be less than 90. We want to keep in mind that the lone pair repulsion is greater than any lone pair bonding pair and greater than the bonding pair repulsion. Therefore, that's going to cause an effect on the angles, and it would also cause an effect on the shape of the bromine molecule. In this next picture that we have here, gives you an illustration on how this molecule actually looks like. As you can see here, you have the 2 lone pairs, and it gives you a T shape because it has the 5 electron groups around it and also the 2 lone pairs. This picture represents the Lewis diagram better than it does with the VSEPR, since the lone pairs are not shown in this model. However, in this model you are able to see the molecule's true shape, which is T shape that has the bent atoms on the sides. So yeah, that is it for this molecule. Thank you.